Yeah, thank you, Luca and Rajat, for your great talk. Are there any questions from the audience? Maybe I can ask a quick question. So it looks like the Hydra system is able to build the same graph, even though there can be a large amount of noise in the semantic masks. Would improving these semantic masks lead to significant improvements in the same graph representation, or is there an intuition of why it's so immune to this noise?
Yeah, it's a great question. Rajat, if you don't mind, I will take this one. So for Hydra, what happens is that in the background, to construct the 3D metric semantic mesh, we perform some Bayesian inference over the voxels. So imagine that a voxel is observed in multiple images. For each image, we're going to compute the semantic segmentation, and then eventually we're going to average out all these different semantic segmentation when reasoning over the label of the voxel. So naturally, this kind of Bayesian inference over the label will kind of mitigate the noise. And that works typically pretty well for large structures. Indeed, if you look at the maps, the segmentation of the walls, the segmentation of the ground is pretty good. But if you would zoom in and look at smaller objects, definitely would benefit from having a better semantic segmentation, because the segmentation, if you look again a smaller object, is not as good as it should be. And again, we didn't put effort in improving the semantic segmentation. We're just using state-of-the-art networks for that. But the next steps for real robotics application is definitely to look into that and looking at more better solutions for the segmentation part. Rajat is already doing amazing work, by the way, on that front. So hopefully that will be online also soon. Again, thinking about self-supervision, in which essentially Hydra would learn about objects and will improve its capability in recognizing objects as it goes.
Great, thank you.